This is the third projectile motion lab, which is project launcher at a target. Similar as the previous lab, Table 1 and Table 2 is also data you can use from projectile motion horizontally lab. I have the projectile launcher set up in the front of the classroom. For this lab, we do need a target. So the target I pick is actually a sink on each table. So first, I do need to measure the distance between the projectile launcher to the individual sink. So after a few measurements, the target distance from the projectile to the first sink was 198.12 centimeters. Since the unit should be in meters, so you might need to do a conversion there. Second target, the second row sink, was 345.44 centimeters. So you still also need to do a unit conversion. The delta x is the distance plus the offset. Now we're going back to table 2. So you probably look back into the table height from the previous lab. It is about 86.36 centimeters, which is almost similar height as a target height. Although we know the projectile launcher, the metal ball was a little bit higher than a table when it was being launched. Technically, when we do delta y, we need to do the target height subtract the launch height. But at the moment, because the sink gave a bigger area to land, so we are going to ignore that. That's why we're going to decide to say the delta y is equal 0, which will help us to do the calculation a little bit easier. Here's a diagram you might need to think about. Right now, for this lab, we do need to find the angle for the launcher. We do know we are going to use the average velocity. Then what is Vx equal to? What is Vy initial equal to? Finding that connection using the time, because no matter what, the time between vertically movement and horizontal movement will be the same.